I'm Kevin Wiebe, the engineering manager at General Energy Recovery. I'm here to talk a little bit about some of the things about direct contact steam generation, give you some numbers, talk about our process a little bit more in depth, give you a better understanding of what's going on. In a once-through steam generator, typically used in CSS and SAGD applications, you mix the air and the fuel, you combust it. The heat is transferred through pipes to a body of water. This body of water is obviously pressurized as it heats up and turns to steam, and the steam is what goes downhole. The emissions from this process are sent to atmosphere. It's called waste gas, and the idea is you want to capture as much heat from this waste gas as possible, transfer it to the water before emitting it into the atmosphere. It's been proven to work. It works well, but the direct contact steam generation is slightly different in that we're mixing everything together: water, natural gas, and the air. We're combusting it, and we're creating that steam almost instantly, and everything is getting injected downhole. There's no emissions to the atmosphere here. This is a 100% closed system, and so the energy efficiency of this part of the process is extremely high. Here's an overview of the Jerry process, how we've developed it. We have electric generators running in the back here. This provides power to the e-house, which is supplying power to the air compressors. It's providing power to the fuel gas compressors, building heaters, lights, control valves, that kind of thing. So in this system, there's three inputs. You've got your air, you've got your fuel, and you've got your water, and these all go into the process building, and from there the steam is created. So here the air is being compressed. Now this is taking air from atmospheric pressure, and it is pushing it up to the injection pressure that you're going to need to inject it into the wellbore. Same with the fuel gas. I mean, obviously now we're coming in with LNG, CNG, or if you have pipeline gas, that's even better. So we're taking roughly whatever pressure it is coming in off of the pipeline or off of the CNG truck or LNG, and we're compressing it up to what the process building needs, like the direct contact steam generator, and we're injecting that at wellbore, at wellhead pressures down your wellbore. The direct contact steam generator itself is fairly small in its diameter. I mean, you could put it downhole. You could run this whole process downhole. Jerry has elected to have this direct contact steam generator in a surface pressure vessel, so it's operating at the same pressure as the wellhead, basically. Couple hundred kPa higher, just because you're going to have a little bit of friction loss going to the wellhead and stuff like that. But the reason for that is when we're servicing or testing our direct contact steam generator, we didn't want to have a coil unit on site to have to pull everything out of the wellbore. And this was just, it seemed simpler at the time. I think it still is simpler. And there's not a lot of heat losses between the process building and the reservoir. You got vacuum insulated tubing all the way down the wellbore. And on surface here, you can see, I mean, these are cladded pipes. You're not losing a lot of temperature from these pipes. Here's I mean, this is the same flow diagram. I just talked about this. So you got your atmospheric air entering your air compressors. Your fuel source is providing fuel to your electrical generators and to your fuel gas compression, which is then pumped into the direct contact steam generator under pressure. You get your water coming in a water tank. It's being injected up to pressure before it enters the direct contact steam generator, and then obviously your three products: your steam, your pass-through nitrogen, and your carbon dioxide is what's leaving the direct contact steam generator. If you have power on site, that would eliminate this big problem. It's not really a problem, but we could just just hook up to the electrical grid. It would be way simpler. Here's kind of the inputs and outputs on the direct contact steam generator. This is operating at 8 gigajoules per hour, very close to it. So natural gas, 2.5 kilograms a minute you're going to need. On the air side, you're going to be pumping in nitrogen, you're going to be pumping in oxygen into this tool. These are the rates: 33 kilograms a minute of nitrogen, 10 kilograms a minute of oxygen, and you're going to need 48 kilograms a minute or liters a minute of water to transfer this energy to steam. You'll notice on the output side that basically this nitrogen just passes straight through. All it does is just heat up. That's it. And then from the reaction here, obviously all the methane gas that you had is going to be consumed. The oxygen is going to turn into CO2 and into water. So CO2, here's our CO2 that's coming out, 7 kilograms a minute of CO2. And we're going to grab a bit more water. So we injected 48.5 liters a minute, and our final output stream is 54. This is a combination of steam and liquid water, and I'll get into kind of how much of each in a second, but I guess the big takeaway here is on a mole percent, 7.5 mole percent is CO2. We don't expect that to corrode or prematurely damage your piping. We've done 4 pilot tests to date, roughly 20 days of steaming for each pilot. We haven't noticed a significant degradation in our piping from the CO2. In fact, we've actually found that when you have excess oxygen in the system, that seems to have a much more negative impact. So if at all possible, you try and feed the direct contact steam generator with a little bit higher nat gas than what you're going to actually pump in from the air side. So you want to actually have on the output side a little bit of nat gas just to keep your oxygen in check. That's the biggest takeaway from that. I don't want to talk about that. I'm going to get over here and kind of show you a bit of our process. So on our fuel side, I've kind of entered in some of the numbers that we had from the previous sheet, or what we've experienced at 8 gigajoules per hour. Atmospheric air, same thing. So here basically your fuel is coming in, it's going through 3 stages of compression, and it enters into the direct contact steam generator. This, pretend for instance purposes, like I guess this would be the direct contact steam generator. And then atmospheric air comes in, it goes through a booster, so we're boosting it up from atmospheric air to around 700 kPa, where it enters into our recip compressor. 3 stages of recip, and it's leaving the recip anywhere from 5 to 7 or 8 MPa. So basically the fuel gas and the air side are both pumped into the direct contact steam generator, where it is combusted. Water is added almost instantly to the direct contact steam generator, almost immediately right after the combustion, and we're able to get a I guess our final product here. The temperature is not actually what you think it would be. So this is running here at around 6 MPa pressure, but our temperature is only 509 Kelvin. So when you're looking at the steam tables and you're like, wait a second, you should be 300 and whatever. It's not. It's actually 200, around 245 degrees Celsius is really what our actual final temperature product is. So it's maybe 60% of your saturated steam tables. That's a very good approximation, 60%. The other thing here is you don't necessarily need boiler quality water in order to operate our direct contact steam generator. The water is added so close to the process, and it's all mixed together and it's all sent down whole, that you don't have the effects that you would have on a once through steam generator where you've got the water on one side of the pipe and all the hot gases on the other, and you have this transfer of energy across a pipe where you're depositing minerals from the water onto the pipe continuously. In our system, it's not really happening like that. We don't necessarily know if you would want to have all these minerals, I guess, going downhole, or all these salts entering into your reservoir. So it's up to you how clean you want your water to be. Historically, we've been operating less than 300 ppm of solids, but it's up to you. In our final product stream here, the other interesting fact is that our steam quality is the molar fraction in brackets vapor, so 70, call this 77% for this specific air, fuel, water inputs. This means that 77% of the water that you've inputted into this system is now steam, and the other 24% is liquids. If you wanted to run a higher salt content in your water stream, or if you just wanted to do hot water heating, we can definitely do that. We just would ramp up the water rates much higher. We've operated our system as high as about 87% steam quality. And the issue with that is the higher the steam quality you get to, the less solids you're going to want to have in your water stream, because the water that's remaining is what's carrying your solids downhole. So at some point you're going to reach that magical number where the water is just not going to handle excess solids in it. This is kind of, I guess, a high overview of what our process is, and I hope you enjoyed this quick little overview of the direct contact steam generator. Thanks.